All right, so this circuit, and this is, there it is, right? This is the circuit we used for our internal resistance of the battery lab, right? This is one of the required labs for IB, so they like to put questions on there that come from the required labs, right? So an ammeter and a voltmeter are connected to the circuit. Label the ammeter with the letter A and the voltmeter with the letter V. I'll let you guys do this. Remember that the ammeter currents flow through ammeters. Okay, so the ammeter needs to be put in the path of the current that will flow, right? Remember that voltmeters are placed across, right? Something. So we're going to measure, say, the pressure difference from here to here. Okay. Remember that ammeters have a resistance of 0, right? Ammeters do, and the voltmeters have a resistance of infinity. Okay. So I'll let you decide where they go. You can just cheat and look at the handout we had for the internal resistance of a cell lab, right? Okay, so as you remember, as you recall, the internal resistance will be the slope of this line, right? It's, what is it? It's, the potential is, it's in the data packet too. They've got this thing in there. Where is it? It's like they've got a whole section on this. Let's see if we can find it. I believe it's just that the voltage is equal to the source voltage minus IR, where that's the internal resistance, right? Okay, I'll look it up. It's essentially that. It might be EMF or something, right? So basically, the x-intercept or the y-intercept will be the source voltage, and then if we just find the slope of the line, the opposite of that slope is the resistance, right? So read that point right there. That's x1, y1, right? Read this point right here. That's x2, y2. Do y2 minus y1 over x2 minus x1. You'll get a negative number, by the way, because it's downward sloping, right? And the absolute value of that will be the resistance. Okay. And then they ask these questions, these awkward questions, right? The ammeter is used in the experiment is an analog meter, and they can't even spell analog. I mean, look at them. A student takes measurements without checking for a zero error on the ammeter, right? A zero error is that when there's no current flowing, it doesn't read 0. It might read negative or it might read positive. Okay? Yeah? After taking measurements, the student observes the ammeter has a positive 0 error. Okay, I believe that means that it reads a positive number. So if you look at the meter, right, here's 0, right? Here's 1. Here's like a little mark. Here's 2. This is like the worst example, right? The needle points like this. So even when there's no current, it's like that, right? Okay. Explain what effect this 0 error will have on the calculated value of the internal resistance. Well, what it's going to do, it's going to translate this line upward without rotation. Yeah? So it'll be a line with exactly the same slope, even though that one doesn't have the same slope, right? It'll be a line that has exactly the same slope. It'll just move both ends of these up by whatever that error is. Yeah? So I'll let you think about that. Is moving this line up without rotating it, does that change its slope? If it does, then talk about that. If you don't think it does, then, explain that. Yeah? All right.